Hey guys, today we are going to be doing our last part of Unit 10, which is the binomial expansion theorem. And so we're going to ask ourselves, how can I find any term of a binomial expansion? Well, first we need to know what a binomial is. And we've actually been doing these for a while now. A binomial is just two terms inside your parentheses and we raise it to a power. So if we go ahead and we kind of expand these guys, these are pretty straightforward. Anything to the 0 power, well, that's just 1. Okay, if I had anything to the 1 power, that's just whatever was there inside your parentheses. We remember, or what we could do here is we could use some FOIL, or there is a formula for a perfect square, and if you FOILed those two out, you would get a squared plus a double times those two terms together plus b squared. And then we also have a formula for a plus b cubed, or you could FOIL that out again and you would get a cubed plus 3a squared b plus 3ab squared, and finally plus b cubed. And we could continue doing that. You could do a plus b to the 4th. You would just have to take these two of these things and multiply them together, but it just gets really messy, especially if they asked you to expand something like x plus y to the 48th. Heck no, that's too much work. And so what we're going to learn is a formula that can help us expand a binomial out. And this is what this formula looks like. So the binomial expansion theorem looks like this guy. So we have a plus b to the n is equal to, and we see that sigma from the summation notation. So this is indicating this is a series. We're going to keep plugging in a number in for k until we get to n. And so we have all of these letters in here. So let's go ahead and define what some of these letters are. So what we have is the first thing is the a that we see. So the a is just the first term in the binomial. So the first term in the parentheses. Okay, and b is going to be the second term in the parentheses. Okay, and then the other parts, this n, if you notice, these n's match. All of these n's are the same thing. And so the n is going to be the power of the expansion. So the exponent on the outside of the binomial. Okay, and then k is going to be your term number. So if I plug in 0, that would be the first term. It's kind of weird. That's your first term, and then your second. You're just plugging in k as we go along. Okay, so that's what the formula looks like. We're going to apply it in a second, but the first thing that you're probably kind of confused about is, what is this weird thing in parentheses? This isn't a fraction. This is what we call a combination, and it's how we calculate the coefficients in front of each of your terms in your binomial. So this is a combination notation. This parentheses thing, we actually call this n choose k, and this is the formula for it. So it's exclamation point all over k exclamation point times n minus k exclamation point. And that exclamation point in math is actually what we call a factorial. And that is the definition for a factorial. So the little exclamation point at the end of a number, it just means you're taking the product of the integer and all the integers before it. So if I had, for instance, 5 factorial, that would be 5 times the next integer down times all the way down until 1. And so 5 times 4 times 3 times 2 times 1, that's just a number. Okay? So let's practice using this formula a little bit, and it's actually really interesting to see what happens when you have factorials. So here's an example problem. This is 8 choose 5. So I'm going to have 8 things. I'm choosing 5 of them. I'm just going to plug them in. So I have 8 on the top, factorial, all over k factorial times 8 minus 5 factorial. And so that's going to get me 8 factorial over 5 factorial and then 3 factorial. Okay, so if I was to write this out, my 8 factorial would just be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on my bottom, I would have 5 times 4 times 3 times 2 times 1, and then 3 factorial is just 3 times 2 times 1. So the interesting thing that happens here is that if you notice, there's the same thing on both the top and the bottom as far as your 5s go. So we actually have a lot of pieces that just canceled out. The 5 factorial completely canceled out. And then I can just simplify this using some math. So I know that 3 times 2 is 6, so this 6 would go away as well. So all I'd be left with is 8 times 7, which is 56. So that is how you calculate a combination by hand. You write out your factorials and you cancel what you can, and a lot of it is actually going to cancel. Now the other thing that you may have seen before, but you might have not, is a really cool thing called Pascal's triangle. And this triangle has a bunch of ones on the sides, and then it has these other numbers. And so in order to figure this out, what you do is you take these two, so you take these two together and you add them together and you'd get that term below it. So 1 plus 1 is 2. 2 plus 1 is 3. And so that's how they're getting these terms. This term down here is just adding the 2 above it. And so it's a really cool sequence that goes on. It's defined recursively, and it's really nifty when you're trying to calculate those coefficients, because if we labeled each of our rows, I'm going to ignore the first row. This is my first row right here, so you could call it the 0 row. And then the second, the third, the fourth, the fifth, the sixth, the seventh, it matches with the first number that's not 1 in there. And if I wanted to find 5, choose 3, I would go to the 5th row, ignoring that guy, ignoring the ones. So this would be my 5th row. And then I pick the 3rd term. I guess I should write row. So the 3rd number. And again, we're ignoring ones here. And so this number right here would just be, well, I totally didn't ignore it, would just be 10. And if we had done it with the formula, we would have found it the same way. But I know you guys are all like, first of all, I don't want to draw this triangle on my paper. I don't really care about another formula. So good thing you have a calculator. You should know how to calculate these by hand. Again, you should know how to calculate them by hand. However, there is a shortcut in your calculator. If you go to the math menu and you go over to probability, the PRB, this NCR, that is what we're looking for. And so you're going to pick the NCR, and then what you've got to do, for instance on this one, is type in, it'll always kind of fill in the answer. You want a 3 though, or a 5 there, and 3, and then we would have gotten the answer of 10. So again, this is how you do it on the calculator. We can calculate combinations if you go to math and then probability over here, and you pick this one. Don't pick P, pick C. So that's how we calculate the coefficient, the number in front of the term. Now what about the exponents and the actual thing? So this is again my binomial expansion theorem, the actual expanding part. Now when you're talking about your exponents, your power on your first term, so the power on your A, is always going to start on the biggest. So it's going to start at the n power, because you know if you were expanding this out, the biggest power of A would be A to the n. So the power starts at n and then it goes down until 0. So every time it's going to decrease by 1 and it's going to eventually be at 0. Now the power on the other term, so the power on B, starts at 0. It's the opposite. It starts at 0 and then goes up to n. Okay, so let's do an example of this. I feel like the exponents are a little bit easier than the actual expansion. So once you see it happening, it makes a lot more sense. So it asks us to expand x plus 2 to the 5th power. So in order to do that, all I've got to do is use this formula. So the first thing you've got to remember is you're plugging in k as 0 first. So our first term is going to be my power on my expansion, choose 0, times, I'm going to take my first term and raise it to the n minus k. And so 5 minus 0 is just 5. And that makes sense. Then I'm going to go ahead and take my second term, which is 2, and raise it to the k power, which is just 0. Okay? That's my first term. Here's my second term in the expansion. I'm going to take 5, choose 1, and then I'm going to take that exponent on the first term and subtract 1 from it. So it's going to be going down by 1 every time. Then I'm going to have 2 to the first power. Okay, and I'm going to keep doing that. So then I'll have 5, choose 2. It's just a pattern. My x exponent goes down 1, and my 2 exponent goes up 1. I just keep doing this. 5, choose 3. X squared, 2 to the 3. I'm going to run out of space. So rude. Aw, it's only moving a little bit. I'll just move on to the second line. Okay, so I have 5, choose 4 would be my next term. and then I'd have my x go down to just the first power, then 2 would be raised to the fourth power, and then finally my last one, my numbers should match. It should be 5 and 5, and then I'd have x to the 0 power, which we know is 1, and then we'd have 2 to the fifth power. So a couple of things to note about this. First of all, your in choose k just keeps going up until it goes down, until it gets to 5. Okay. The next thing is that these exponents in here are always going to add up to your total power. So if you notice, all of these add up to be 5 in the end. And now this 5 choose 0, 5 choose 1, whatever, those are just numbers. And there's lots of ways you could figure that out. You could use your calculator. So if I wanted to type this into my calculator, I'd do 5 math over to probability number 3 and then 0. And I find out that that's 1. Okay, so this whole number is just 1. I'm going to write it right here. Okay, and I can continue doing that in my calculator. The other thing you could do is you could look at Pascal's triangle. We have a fifth power expansion. We have 5, and so my coefficients would be 1, 5, 10, 10, 5, 1. Okay, or you can use that formula. So I know that 5 choose 1 is just going to be 5. 5 choose 2 is 10. 5 choose 3 is 11, 2, I don't know where I got 11 from. 5 choose 4 is 5, and 5 choose 5 is 1, using any of those methods. Okay, now I just have some multiplication. Remember, anything to the 0 power is 1, so I don't have to worry about that. So my first term is just going to be 1 times x to the fifth. My second term is 5 times 2, so 10. 2 squared is 4, so I'm going to take 10 times 4 is 40. 10 times 2 cubed, that's 8, so I'm going to have 80. I keep running out of space. 2 to the 4 is 16. So 5 times 16 is, I don't know, I'm not that great at arithmetic apparently. 5 times 16 is 80. And then finally, it's just going to be 1 times 2 to the fifth, and 2 to the fifth is 32. And so this would be my complete expansion. So all I did there is I calculated the coefficients using my n choose k, however you want to think about it, with your calculator, with the formula, or with the Pascal's triangle. Then I listed out my exponents. Again, these went down. The first one goes down, and the second set of exponents goes up until you hit that final power. And then you just multiply everything that's a number together. Now, the other thing that you might have to do is they may ask you for a specific term. So find the seventh term of this particular expansion. The hardest part about these is to know that when they ask for the seventh term, if I go look at my expansion formula, k starts at 0. And so if k is starting at 0, what I actually have to plug in for k is going to be whatever this number is, the term number minus 1. So what I need to plug into this here is 6, because that will get me that sixth term. So what I would do here, I take my total expansion, my 10, then I'm going to put in the 6, and then I have my two terms. I have x squared raised to some power, and I have 2y raised to some power. Now the easiest way I know that this works is if you look at this formula, this k, this choose thing, is always the same as the exponent on the b. So I know that this exponent on this guy needs to match right here. So this should be a 6 in this exponent. Okay, and then I know that the exponents need to add up to be the total expansion. And so I know that 6 plus what gives me 10? Well, this would be the fourth power. And now this is just a matter of simplifying this down. So I could go into my calculator and calculate 10 choose 6. And I get 210. X squared to the fourth is going to be x to the eighth. Be careful on this one. 2 goes to the 6th, or sorry, 6 goes to the 2 and to the y. So I'd have 2 to the 6th times y to the 6th. And so if I went into my calculator, I do 210 times 2 to the 6th power. And so I would find that my complete expansion would be 1, 3, 4, 4, 0, x to the 8th, y to the 6th. Okay? So that's how you do binomial expansion. Whew. I am not going to be here tomorrow, so I just wanted to kind of point out some useful things That's why this video is probably a little bit longer. First of all, you need to complete your Google form in order to get your notes credits. So the link should have been sent out through Remind. Otherwise, go check my website. So the first thing is that there's always one more term than the exponent of the expansion. If you think about x plus y quantity squared, remember that was x squared plus 2xy plus y squared. So it had 2 as the exponent, but it had 3 terms total. So that's just a useful thing to remember. You're always going to have one more term than you do exponent. The exponents on the terms are always going to add up to the exponent on the expansion. So if you look here, this exponent is a 2, there's a 2. This exponent would have been a 1 and a 1, they add up to 2. So all of your exponents on your term should add up to be that number in your exponent on the outside. Okay, the exponent on the second term will always match the bottom number of the combination, and that's what we talked about over on this guy. How if you were looking for the 6, this exponent is going to match that number there, always. And finally, these are some common combinations that you're going to see. Whatever number choose 0 is always going to be 1. Whatever number choose itself is always going to be 1. If you have in or some number choose 1, it's going to be that number. So 5 choose 1 would be 5. And then in choose n minus 1. So if I had 5 and then the number underneath that is 4, that's just going to get me 5 as well. Okay, and you can always use your calculator for that. That's just kind of a shortcut. Okay, if you have any other questions, please feel free to send me a message on Remind or whatever, and I will see you guys on Monday.